YouTube or we're live streaming to Twitch. We're always looking for more speakers, more topics, interesting ideas. So if anybody has any suggestions on topics or speakers they'd like to hear or see, or if they wanted to volunteer themselves or their coworkers, then be sure to let us know. We will be going probably to the Avenue afterwards for drinks on your own dime and maybe some food if our food doesn't show up. So please join us and drink responsibly. With that, do we have any other announcements or anything before we get started? All right. So with that, we'll hand it over to Travis.
Hello everybody in St. Pete and watching live on YouTube and Twitch. My name is Travis Stark and I'll be giving you an introduction to ML.NET. So first, the agenda for today, I'll tell you about myself first, and then we'll go into what is ML.NET, and then we'll go into an overview of the features, then we'll do a couple of demos to show some of its features in action. So about me, I'm a software engineer at Webstrong Store in Tampa, and probably 8 or 9 people from the office here right now, over there and back there. And at the office I work on a .NET Core API that uses Elasticsearch to collect products based on product search to turn to the front end. Outside of work, I enjoy traveling and playing sports in my free time. This is us in Vancouver, my girlfriend and I, Colleen. So, what is ML.NET? ML.NET is a cross-platform machine learning framework for .NET developers. It allows you to create predictions from past data that you've collected using C# within your existing document or .NET project, so that we don't need to learn Python for TensorFlow or any of the other kind of languages for machine learning. So what are some possible uses for ML.NET? You can, for any situation where there's enough data that you've collected, where you can train a model on, you can pretty much use ML.NET. So you could do sentiment analysis, where it's binary classification, where, so you can, if you have customer reviews or messages, you can detect the data if it's positive or negative sentiment, and then predict a current or a new message if it's also positive or negative, so you can filter those out or do other kind of testing with them. You can do product recommendations based on past purchase history of a customer, price prediction, which uses regression to estimate fares. Then you can also do object detection, such as facial recognition or like detecting street signs or roads, kind of like the Google captcha kind of things where you point out street signs. And then there's a lot more that are also available. And you can see samples of all of them on the Microsoft.NET Machine Learning Samples repository. So what is the basic workflow for using ML.NET? Before you can do anything with the ML.NET itself, you have to make sure your data is organized. So you would need to filter it out and find out what is relevant to what you're trying to predict. So for this example right here, you have a user ID, movie ID, and a rating that goes along with the movie, and then a timestamp of when the user submitted the rating. So for these 4 field columns, you would only really need user ID, movie ID, and rating. Timestamp isn't useful for predictions, so we just remove that from the model. And then after you've selected the useful columns, then you need to decide what would be your features and your label. Features are columns that are used to create the prediction, and the label is the column to be predicted. So we would use the user ID and movie ID as features, and then we want to predict the rating, so that would be the label column for this example data set. So after organizing your data, then you have to create models for training and prediction. So this is a different example, but same idea where you're calculating house prices based on different attributes such as size, and you can have many more fields like color, location, number of rooms. So those would all be attributes within this house data object. And then you would also create a prediction object which would hold the label that you're trying to predict. As you can see, we're trying to predict the price, so we create a price field within the prediction object and give it the column name score. So after creating the models, you have a main program file. The first step always is to add a ML context right here, which is basically the introductory call statement that you need whenever you're using ML.NET, and you'll see that a lot more tonight. And it allows you to use data preparation, feature engineering, training, prediction, and model evaluation components. So after adding that, then you would load or create the training data from a file, SQL database, or an inline object like this one. So this we create 4 house data objects with size and price of each. And then we would load those into the training iData view interface. So then after loading those into the training data interface, you then have to prepare data for training by applying a transformation, which then allows you to add a trainer onto it. A big part of also making sure, in addition to making sure your data is good, you also need to make sure you have a good training algorithm. So those are the 2 longest steps probably in this whole ML.NET process. So for this one, we are using a concatenate transform, because they're all flip fields, so we can just push them onto one object, and then doing a regression analysis or algorithm with this one. So then you create a pipeline after the transform and an application of the regression algorithm. And then after that's how you create your model, build your model. So then to train your model, there's this fit method within the ML context where you apply the training data that you created in the earlier object, this one, fit it to the training pipeline that you built in the step above. Then the final step is to make a prediction. This you would insert a new independent object that isn't in the training set, and then there's a create prediction engine method where you feed the data, the training data, and the prediction. And once you append the predict method at the end, it finally runs the training model, because those are lazy runs, so they only run when you call them, and that returns the predicted values for this model. And for this one, with a predicted size of 2,500 square feet, it predicts the price to be 261,000. So this diagram shows a diagram version of the basic code that was written before. So you start here with the collect and load data using the iData view. Then you create a pipeline using the append method, and then use an estimator to fit your model to be trained, and then you would evaluate it to improve your model, and then just continuously iterate through this process until your model has a pretty good accuracy, like above 80-something%. And then you could save your model once you feel happy with the percentage of accuracy. And then after that, you can then use your model using the load model with the transformer and then the create prediction engine method. Do you have any questions so far about this?
How do you measure the percentage of the accuracy?
The ML context has some methods within it that you can access. So then you can either print those to the console or...
Okay.
How long should you let that model run for?
I have one later that I ran for 60 seconds, but if you have a small data set, you do 10 seconds. But the longer you run it, the better.
When you say your model, what is that? Is that an algorithm? What is the model itself?
not actually sure what it saves it as. It saves it in a zip file of some sort, but I think it's I think it just saves the formulas that were used.
Also, did you run a regression test? It's been a little while for my math, so you want to kind of explain the regression test as opposed to data processing regression test, which I assume is different.
Luckily, the documentation contains a good explanation of what all these methods will be. So I can't exactly remember what regression would do off the top of my head,
Oh, okay.
but yeah. So
It's a separator,
yeah,
and then populates.
Yeah.
It's a long process.
Okay. That's very good.
yeah. So everything is explained pretty well within here. Or if you hit up 12 in your Visual Studio, you can it gives you like pretty good descriptions of what each estimator would be. Okay, so for the next section, we'll be talking about ML.NET Model Builder. Model Builder is an extension for Visual Studio that allows you to easily add ML to your project. This one has a user interface and doesn't require you to have any prior ML experience or know any of the complicated algorithms like regression. So this is a lot better for an initial start. You can easily download this from the Visual Studio Marketplace, and it's been pretty popular already with 47,000 downloads. So for using the Model Builder, we'll create a sentiment analysis demo for the I mentioned earlier, where you can detect positive or negative text. So for that one, we'll go ahead and create a new project, new .NET Core console app in Visual Studio. And then first step after creating the project would be to, since you have the extension downloaded, it allows you to, after you right-click on the project up here, it allows you to then add machine learning, which is a new option that was added with that extension. And then once you go inside of that extension, it gives you this menu where you can choose different scenarios that you want to run. So for this one, we'll go ahead and choose the sentiment analysis. You can also do issue classification, price prediction, or custom scenario of your choice. And then once you've selected that, we add we choose which file we want to use. So for this one, we're using a CSV file that I found, because the actual demo, the data they provided didn't actually work after running it. So I had to go find some new data.
Does it have to be a CSV file?
You can do CSV, TSV, or SQL database.
Okay.
And just columns is all you need. Yeah, so here's the example file that we're using this time. And it has 0 means negative sentiment, so a lot of negatives. But it has, I think, 6,000 rows. So then after adding that file, it gives you a little preview down here, and you'd want to choose which column you're trying to predict. So for this one, we have sentiment and text. So we would want to predict sentiment. So we select that one. We select the sentiment column here. And then after adding the data file, we then go to the next section where you train. So as I mentioned earlier, we use 60 seconds here for training. And then just hit start training. And then it runs several different algorithms over your data, and then outputs the accuracy of each one and decides which one is the best one it should use for this data set. So this is how it's running through each algorithm as it goes. And so for you can see the best accuracy is 82% using a logistic regression algorithm, but it can vary on which one it decides to use. And then at the very end of runtime, you then get an output to the console showing the top 5 algorithms and the accuracy of each one. So then when you go to the evaluate section, it then takes that output from the console here and puts it up here in a table form and shows you training time and number of models run, which is 95 for this data set. So then if you feel okay with that, or if you don't feel okay with that, you can run it again over a longer time until you get an accuracy that you're desiring. So if you're okay with it, then you can go to the code section, where then you can add the projects that are generated to your solution. So this one, after we've done that, it provides you a starter boilerplate code you can add in to your main program.cs. But we're going to go ahead and go into our file, and you also need to add a reference to the new generated projects, which are up here. These two were generated by it. So we're going to go add a reference to the ml.model project that was added. There's also a ml.console app that was added. So after you've added the reference, you also need to add the NuGet package to your project, which has a pretty easy name, Microsoft.ml. So once you've added that to your main project, then you're pretty much up and running after you added the ML context and related training and usage methods to your main file. So we're going to go ahead and add those here. So you have the ML context again here, and then the iTransformer, where we transform our data from the input data files, and then run our prediction image here, engine here. And then after you have a prediction engine, we can create some test data. So for the test data, I added some input text. We're trying to see if it's positive or negative sentiment. So for this one, we're going to say traveling is a lot of fun. And what do you think the sentiment should be from it? So after you hit run, it's a console app, so it's all pointing to the console. And it looks like it predicted a positive sentiment with a score of 2.7, so that's pretty good. So let's see if we can get a negative sentiment to be predicted correctly. So I'm going to change it, instead of traveling is a lot of fun, to traveling is not a lot of fun. Doesn't sound very good. So after we run that, we get negative sentiment, and about the same score, just in the opposite direction, negative 1.9. We could try some more text in Visual Studio with that. Do you have any suggestions?
Like, I hate travel.
stpete.net is great. So we'll go ahead and run this and see what the prediction is. Yeah, it looks like positive sentiment with a score of 7, so that's really high. So it's pretty fast, as you can see too.
Suppose you put in something like I loathe travel, and it didn't know the word loathe was. What would it do?
The number of things that either is nowadays.
Yeah, so that works.
I didn't know.
I mean, it runs a dictionary.
It doesn't actually know that word, so it gives it positive sentiment.
Ah,
Yeah,
That's why it's 80-something%.
Yeah. Yeah, 'cause you need to have a massive data set to train it with.
If you do like some neutral, like okay, is it just like a really low score, like a 0.1 positive or something like that? Traveling's okay. Traveling's all right, I guess.
Yeah.
Take care of that.
Maybe I might like travel with you. That's a good question. I'm really curious to see what that was.
So give it positive with 1.9.
How about I never miss an opportunity to travel? Basically, it's.
Oh, I get you. Negative, and this negative.
And it's also pretty low with a negative 0.6, so it's neutral.
Travel sucks, so or something like that.
I don't know.
Traveling is the pits.
Well, that's why you have to learn old school.
Yeah.
Get more word in the dictionary.
Look up the word that means the dictionary. That's all I'm
Needs
saying.
more to draw off.
No,
It's a baby.
I know it doesn't know nothing. I know it's
Computer experience.
Negative. Yeah. Whatever words are in the data set is what it'll know.
Does it get better over time?
Yeah, if I ran that for like,
As like this program, you're adding more input data.
The more input data you got, the better the output.
Yeah,
yeah, I
but
don't
even
think
after
this
the
is adding it.
model is still get better and better.
Yeah, I'm not sure if this one is adding because it's just accessing it.
Oh yeah, this
Yeah, I was just saying, it's like when you're trying it out here, it's not adding that.
No, I think it's
knowledge.
just reading from the data that was previously trained.
Really get better you.
But if I added like 1,000 more rows of text and then ran it for like an hour or so, it'd probably have pretty good accuracy.
I was gonna
So
say,
you
a lot of.
you can append, like if you collect more training data, can you append it or do you have to start over and create a model?
I'm not sure actually. I guess you might be able to, but
It looks like you probably have to start over, like,
Yeah, I
and
think so.
with new training data and do another model.
yeah, because we could.
I think you.
I would think you could load an existing model and then train.
Okay.
It really depends on the algorithm you're using. I don't know which ones they have available. Some algorithms are easily trained after the fact, and some basically need all the data.
And that makes sense, sure.
So here's how it looks
This
if
is
you,
the negative, right?
if you were to train it for 120 seconds.
Machines sped a long way. We're not the smartest on that.
I'm actually curious what kind of, I'm looking at the algorithms now. I've used these.
All these are listed on the documentation too, and they have like a giant list of them.
I'm seeing a lot of SEN in there.
Yeah, they have a lot of,
And it has to draw
I think
more
S-
information.
S, G,
It's
or
like
something.
Right.
I'm seeing a lot of
It's the next experience. But you just keep on writing. And eventually.
So I'll let this run and then we can come back to this to see how the accuracy is.
Yeah, machine learning.
So any questions on this demo?
So they have first word.
Okay, our next demo is movie recommendation, and this one uses matrix factorization, which it'll be a console app, so it'll predict whether a movie should be recommended to a user based on their previous reviews and other users' reviews. So this is the one where we have the user IDs and movie IDs and the movie ratings that we saw previously. So matrix factorization relies on past user ratings across all the users. So if user 1 and user 2 like the same movies, then it assumes that user 2 should like a movie that user 1 has watched and liked, but they haven't seen yet. So user 1 likes Incredibles, The Avengers, and Iron Man, but user 2 has only seen Incredibles 2 and Avengers. It would assume that they'd like Iron Man as well. So we'll need to decide which are our feature and label columns. And for this one, user ID and movie ID would be the features, and label, the predicted column, would be the rating. And this also has a secondary database that, or table that relates the movie IDs to the actual movie's name, like Toy Story is number 1. So for this, we have to create our data objects as well, the movie rating class and the movie rating prediction class, which loads the columns from the CSV into the user ID, movie ID, and label columns, and the predicted data that just loads the label and the score. So for this, we again use the ML context again to start it all off, and then read our text file into a training data view again, just like in the previous demo, the first demo. And then we use the matrix factorization trainer to transform the data into a format that's readable by that, which needs to encode the columns. And then we also have to specify options for the trainer, such as column names, which are user ID and movie ID. And then we also specify the number of iterations, which for this one we're going to use 50 iterations. And then the last step when building a model is to create the training pipeline, which you append to the data processing pipeline, which was created in step 3, the recommendation followed by the matrix factorization. And then you then train the model by fitting to the training pipeline again, as just like in the previous example. And each of these methods, or new methods, has pretty good descriptions within, if you hit F12 in Visual Studio, so it's pretty nice and it lets you figure out what's going on. And some of the wording's pretty nice, like this one is just training pipeline dot fit, and then the data you're trying to fit. And then we would then verify the model accuracy on a new test data set that's separate from the training set. So we have a training set and a smaller test set that doesn't have any related values to see what the accuracy is. And then after that, we then can test on a single set or a single object. So we're going to create a prediction user and a prediction movie ID. So we'll use ID 6 and movie ID 10, which happens to be GoldenEye. So then we then run the movie rating prediction using the .predict method again on this user ID 6 and movie 10. And then we round the prediction to get 1 to 5 stars rating, and then if the rating is above 3, we'll recommend the movie, and if it's below 3, then we'll not recommend the movie. So let's see if it's recommended for this user. And it looks like it was recommended for them. They got a 3.7 as their predicted rating. And how about a different user? Let's see if they would be recommended this one. So this user number 3, has a predicted rating of 1.5, so they must have liked different movies than user 6 did, and it's not recommended for them. I created a custom user with a different ID that has only rated these 5 movies and gave them all 5 stars. So, do you think that based on these movies, that this user would also like to watch GoldenEye?
Yeah.
And the
Cult classic.
the model.
In this country. What if the model that doesn't show our country?
So if we run this one with user 1000, it predicts that the user
I think it hit a breakpoint or an exception.
I think it is.
Some model strange.
Oh, save this. Well, this user was predicted to also watch it because they're all kind of similar movies. So the main takeaway from all this is make sure you have good training data, because if you have bad data, then that means you would have pretty bad predictions. And larger data sets and larger training time helps create better predictions. So, any final questions?
What percentage did we get to?
For which
Oh
one?
yeah, the one you ran, you know.
Eight up by 4 points.
Oh, yeah.
83.27 to 83.6.
Just run up 10 minutes.
Diminishing.
I'm just curious.
Yeah, right.
Using like ML in like a production yet or anything, or it's just kind of just a hobby right now?
I haven't used it in production yet.
Okay.
Yeah, just a hobby, because it officially came out in April.
Yeah, I know that's pretty.
So what, can you run down the versioning really quick? So it's in release, right?
Thank you.
Okay, okay, so it came out in April. And what version of Visual Studio were you on?
I was on 2019.
Okay, do you have to be on 19?
No.
Okay, and what version .NET Core? Because you said we're on a Core, right?
I think I'm running 2.2.
Okay.
I don't think it requires too much besides. Yeah, it's pretty good documentation on here,
Yeah, I would assume it's all there.
and unfortunately, some of the demo data doesn't work. So the sentiment one, so I had to download a secondary database.
Yeah, TV broke.
But I think it works. I think you just need .NET Core, and it works cross-platform as well. The model builder I think is only available on Windows Visual Studio.
Has Netflix been using this model?
I'm not sure.
Netflix is definitely overtrained.
Yeah. We need their database.
You watch 3 action movies and then that's everything.
Is that how it works? I mean,
But you can see over time how they're able to.
well, they give you categories, and then they give you just a topic overall.
Is there anybody big time that's using that you know of?
Um,
Like Netflix?
I think they do actually list out some of their users.
Fairly sure Google's not using it.
Oh yeah, I think they're using TensorFlow probably.
Oh, sure.
Yeah, Python is basically the standard for now, at least.
Yeah.
The big reason for that is because of the exploratory data analysis aspect. With that kind of exploration, it's good to have a very fluid environment. And once you basically nail something down, then you implement it in C# or C or what have you, and then it's solidified, but it's a lot faster.
Looks like they use it in their own products because Outlook and Power BI both use it. And the nice thing about this one is you don't have to learn a new language for it if you're already using C# in your project.
This TV is fancy doors.
So the demos are
Thank you.